We're going to look at similar triangles and some examples involving similar triangles. So it says here, which of these pairs of triangles are similar? Let's look at the two green ones at the top first of all. So in order to work out if they're similar, we need to find corresponding angles and see if they're the same. So let's look at all the angles in the triangle and try and work them out. So at the top, in this triangle here, we've got 90 and 67. Now 90 plus the two ones over here, another 90 comes to 180, so 67 plus this one must make up to 90. So that means that one must be 23. So we've got 90 and 67 over here, so again that must come to 23. Now if we look at corresponding angles here, we've got a 90 and a 90, we've got a 67 and a 67, and we've got a 23 and a 23. So corresponding angles are the same. That means the triangles are what's called equiangular. All angles are equal. So make a wee statement, triangles are equiangular, therefore the triangles are similar. Okay, let's look at the ones at the bottom here. So the same principles, if we can find all the angles first in each triangle and match them up, match up corresponding angles and see if they're the same. So we've got a 34 here and 123, now that comes to 157. So we need 23 up here to make it up to 180. Now straight away we can see 23 and 22 here, so corresponding angles are not the same. Now that means that the triangles are not similar from that, so you can make a restatement saying triangles are not equiangular, all angles are not equal, so triangles are not similar. Okay, let's look at the same idea, except we'll look at ratios of sides this time. Now the easiest way to do this is to make the triangles look exactly the same, so you can find the corresponding sides. Now the triangles, this triangle really looks like that. So that 4 is come round to the bottom, so really that 4, we'll put it there. And that 10 came round and went up here. So if you're looking at corresponding sides, then the 4 matches with the 3 and the 10 matches with the 7.5, just from spinning it round. So to get the scale factor, the reduction scale factor in this case, taking the second number divided by the first. So we'll do the yellow ones first, so we'll do 3 divided by 4. Now if you know your stuff there, that should come to 0.75. So it's 3/4, so 3 divided by 4 is 0.75. Then if we take the second green one and divide it by the first, divided by 10, again move decimal point back, you can see it's 0.75. So that works out. So the ratios of corresponding sides are the same, therefore the triangles are similar. Restatement to finish. Okay, last one here. Again, we need to turn the triangle round to make it look the same. So this triangle really rotates round. You see the 4, see the 4's on this side here. So it's coming round, the 4's up here, and then it's going to move round to there. So the 4's actually over here. So we'll put it there. Now the 6 came round from the bottom and went to the top here. So that's actually 6 up there. Okay, it's now easier. I mean, you could have it at an angle like this, but we can see, hopefully from that, that 4 is the same as that 2, and that 6 is the same as that 5. That's the corresponding sides. So straight away here, if I'm doing the 2 divided, the second shape divided by the first, 2 divided by 4, I know that's a half. I mean, you can try it in the calculator, but you should know that 2 over 4 is a 0.5 or a half. And you should also know that 5 divided by 6 is not going to give us that 0.833333. So this doesn't work. Okay, the ratio of the sides are not equal. The triangles, I'll just change that. Actually, it says are similar there. It should say are not similar.